Welcome to my presentation. My name is Andreas Klein. I'm working in the Faculty of Technology at the University of Applied Sciences, Emden-Leer, Germany. And the topic of my presentation today is measuring user experience quality of voice assistants. Let's start with definitions. User experience. A well-known is given in ISO 9241-210. This definition considered user experience as a holistic concept that includes all types of reactions, before, during, and after use. A different definition viewed user experience as a set of distinct quality criteria that includes the classical usability, like for example efficiency, and non-goal directed criteria, for example stimulation. Voice assistants. We can find various definitions. A good choice is, according to Michael Cohen, mentioned in many publications. A voice user interface is what a person interacts with when communicating with spoken language application. So let's bring things together. Why measuring user experience quality of voice assistants? Voice assistants are high available and have great future prognosis. Measuring user experience can be a useful tool to evaluate and improve voice assistants. Existing tools measure the usability, but this is not enough. We consider the complete user experience, also the non-goal directed criteria. To achieve this goal, I'd like to talk about an approach to a flexible evaluation of voice assistant systems. The method based on the UEQ Plus framework, that is a modular extension of the user experience questionnaire published by Martin Schrepp and Jörg Tomaszewski last year. It contains 16 scales to measure different user experience aspects. These scales can be combined to create a product-related questionnaire to cover a given research question. So current scales describes user interaction with the product mainly with graphical user interfaces. But we have no scales for products with voice user interfaces. So here we have the research gap as follows. User experience quality of products with voice user interfaces cannot be captured so far. Graphical user interfaces and voice user interfaces differ significantly because hearing and voice function differently than the eyes. To close our research gap, we have to construct scales to measure user experience aspects of voice assistants. But what are the user experience aspects of voice assistants? Hassensahl and Traktinsky conclude that three components significantly influence user experience in human-computer interaction. The following table shows those components compared to derived scales for voice user interfaces. So we have first component user and scale response behavior. Second component system and scale response quality. And third, component context and scale comprehensibility. An example for the semantic interpretation is here for comprehensibility. The intention of the user is recognized. Okay, study for scale construction. Now we can construct a pool of candidate items for the three relevant user experience aspects just described. Integration into the UEQ Plus framework using the special modular scale format looks as follows. Here we have, for example, a response behavior. An introductory sentence sets the suitable context. This is here, in my opinion, the response behavior for the voice assistant is. And this is followed by items as a semantic differential with a 7-point Likert scale. And here we have, for example, technical, human, artificial, natural, and so on. Our study for scale construction was done in German language. The online questionnaire with all candidate items was sent to students and members of the University of Applied Science Emden Leer. A total of 96 persons participated voluntarily. Average age 35 years. Results. The voice assistants rated by the participants. Here we have 35 Alexa, 27 Siri, 26 Google Assistant, and 8 others. We conducted a factorial analysis of all item sets, means a total of 30 candidate items. A principal component analysis confirmed our assumption of 3 factors. So we consider here the Varimax rotation with highest loadings, factor 2 for response behavior, response quality high on factor 3, and comprehensibility high on factor 1, low on the others. Details analysis is described in the research protocol. So let's have a look to response behavior in detail. The table shows the item set with corresponding loadings. Item 2, 6, 7, and 9 with the highest loadings are selected with an introductory sentence as follows. In my opinion, the response behavior of the voice assistant is artificial, natural, and so on. Response quality. So here we have the table. Highest loadings are found in item 3, 4, 5, and 8. And the introductory sentence is as follows. The answer and questions asked by the voice assistants are inappropriate, suitable, useless, useful, and so on. Okay, and last, comprehensibility. The 3 highest loadings on factor 1 are item 1, 4, and 8. Item 8 falls out because it already charges factor 3, item 9. Item 2 and item 6 with identical value move up, but it overlaps with the existing UEQ plus scales. So the final decision is as follows. Item 1, 2, 4, and 9 with introductory sentence. In my opinion, the voice assistant has understood my voice commands, complicated, simple, inaccurate, accurate, and so on. Finally, I'd like to present 2 examples to create a product-related questionnaire. Selecting relevant scales, experts recommend looking at the product-specific user experience aspects first. So further criteria can be essential, for example, for marketing, but not for users. More information is available at the UEQ Plus handbook. It's free of charge. Okay, let's start create a questionnaire. Example number 1 for a study with users applying smart home devices for general tasks like asking questions or online shopping. Here we pick the first 4 existing scales: perspicuity, trust, trustworthiness of content, and quality of content, followed by the 3 new scales for voice quality. In the second example, a questionnaire for users surveys that use voice assistant systems, for example, in administration area for a customer service. And here is the focus on accessibility and data security. And we select efficiency, perspicuity, dependability, and trust, as well as the 3 new voice quality scales. Okay, conclusion. This presentation shows an approach to a flexible evaluation of voice assistants based on the UEQ Plus framework. Closing the gap inside the UEQ Plus, 3 new scales were constructed, especially for voice assistants. A study for scale construction was conducted with an online questionnaire, and the factorial analysis of the data confirmed the assumption of three scales: response behavior, response quality, and comprehensibility. Each scale with four bipolar pairs of items. Finally, two examples showed the creation of a product-related questionnaire to measure user experience quality of voice assistants using UEQ Plus framework. And here we have references. And thank you very much for your attention.